So today we'll be talking about Boyle's law. Boyle's law describes the relationship between pressure and volume. So, in order to remember this, we need to boil our potatoes and vegetables. So we see that pressure is P and volume is V. As we talk about more gas laws, we're going to see the moles represented by N and temperature represented by T come up more frequently. In this example of Boyle's law, we're going to actually hold them constant so that we can get this relationship of pressure times volume equals some constant value. That means that a system of an ideal gas with a pressure and a volume can be related to a new pressure and a new volume at a later state, and both of those variable or values are related by some constant measure. While we do these calculations, we're going to follow 5 steps. The first step will be to underline all important information. So out of our word problem, we'll be underlining all the things that we believe are variables for the problem we're going to do. Second, we're then going to write out our givens and our unknowns. So we might have 3 givens, we might have 4 givens, we might have 8 givens. Usually we're only looking for one unknown. After we figure out our givens and our unknown, we will determine what equation to use. So right now we're talking about Boyle's law. So we know that our givens will be pressure and volume, and our unknowns will be some other pressure or volume. After that, we will take the law and plug in our givens and unknowns with units in order to solve our equation. Now let's do a problem. In this problem, an ideal gas begins with a pressure of 2 atm, or 2 atmospheres, and a volume of 3 liters. The volume of the gas increases to 6 liters. We're looking for the new pressure of that ideal gas. So as we said before, we're going to underline our important information. We said it begins at a pressure of 2 atm and a volume of 3 liters. We also see a new volume of 6 liters indicated by the keyword increases. It could have also said decreases. We're going to then try to find a new pressure. This will be our unknown. Let's now identify our givens and our unknowns. So we have an initial pressure, P1. That's equal to 2 atm. And we have a volume, V1, equal to 3 liters. We see a new volume, V2, equal to 6 liters. And we know that we are trying to find a new pressure, P2. So we've just finished number 2. Now we need to determine the equation or law that we're going to use. So, because we have a pressure and a volume, and a new pressure and new volume, we're going to boil our potatoes and vegetables, so we're going to use Boyle's law. Boyle's law, as we saw before, is P1 times V1 equals P2 times V2. We're now going to plug in the values. So P1 is 2 atm. Notice that I'm using units. And V1 is 3 liters. This is equal to P2 times a V2 of 6 liters. To solve this equation, all right, since we both determined the law and plugged it in, to solve this equation, we're going to start by dividing by 6 liters to get P2 by itself. Notice that whatever we do to this side, we also do to the other side. And then we want to look to cancel units. So we see that liters cancels on both sides. And then on the right here, the 6 cancels as well. This means that we're left with 2 ATM times 3 divided by 6 equals P2. So, we're going to pull out our calculator. We're going to plug in 2 times 3 divided by 6. And we find out that our P2 is equal to 1. And we're not going to forget our unit, so it's going to be 1 ATM. Notice that we started with a pressure of 2 atmospheres in a volume of 3 liters. The volume increased. Recalling that Boyle's law is an indirect or inverse relationship. As volume increases, pressure should decrease. So as we see, as volume increased, the pressure decreased from 2 ATM to 1 ATM.